Hello. Today I want to talk about my research, which is next generation CO2 conversions to fuse using piezoelectricity and string engineering. So why do I want to do this? The first thing is that because CO2 is not good, and we're experiencing increasing CO2 emissions these days. The other thing is that we're using more and more energy as well at the same time. Yeah, can we convert CO2 to energy? That'd be great if we can do this. And yes, catalysis is the approach. But when we talk about catalysis, we either talk about electrocatalysis, which uses the electricity, or we talk about photocatalysis, which uses the solar energy. But what about other energy sources? How about mechanical forces? For example, in a larger scale, we can talk about the water flows. Or maybe in a smaller scale, how about the strained lattice in the crystals? So what's the mechanism behind this mechanical force promoted CO2 conversions? The first thing is that I want to use mechanical force to induce piezoelectricity to promote photocatalysis, because this piezoelectricity can promote the separation between the electrons and the holes. The other thing is that in terms of string engineering, I can use string engineering to tune the catalyst reactant interaction. So in this way, I can promote the catalysis. So what I'm going to do is the first thing to design nanomaterials and systems to utilize piezoelectricity to promote CO2 conversions. For example, I use zinc oxide nanorods grown on these flexible substrates. I use these nanorods as nanogenerators to generate piezoelectricity and use this electricity to promote the catalyst performance. As we can see, we have some catalyst on top of these nanogenerators. So in terms of strings, we can either use lattice strings that comes from this lattice mismatch between materials. For example, we can have this core shell structure that has lots of strings at the interface. The other way to do it is to induce some large-scale strings. We can use this machine to extend this catalyst and to induce some tensile strings. But the problem with this setup is that we do not have this tensile machine in nature. So I want to design some systems that uses the mechanical forces in the nature, for example, wind and tidal. So what I want to achieve in this project, the first thing is that I want to increase the conversion efficiency by reaching a higher activity. The other thing is that I want to increase the selectivity, which means that I want to produce more C2 products, even liquid products that are very dense in energy. And that was a brief intro to my research. Thank you very much for your attention.